to either side. Now we will focus primarily on visualizations. A good readout to your audience often includes compelling visualizations. In this section, we discuss a histogram, which communicates the frequency of a single variable. It turns out a lot of the things we measure in the world look something like this. This is the distribution of human weight from a sample. The most frequent value is the highest point with weight values less numerous to either side. Here's more data representing minutes for pizza delivery. Yes, pizza delivery will affect your weight, but really these two data distributions aren't related. In both cases, the highest point is in the middle of the distribution. Put another way, the most frequent value is the highest point. The curve here is symmetrical, meaning it flows to either side of the point. The resulting shape is similar to a bell, so this distribution is often called a bell curve. In fact, a bell curve is so common it is technically called the normal distribution. This is a histogram of a normal distribution. Again, notice the peak in the middle and the symmetrical slope to either side. Instead of the smooth curve in the last slide, the rectangular bars grow as more data is within that value range. For example, the most number of values in this data is 10. Thus, the highest bars are on either side of 10. In this chapter, you will learn to see the relationships between the histogram visual and the summary stats you learned about before. Overlaying the smoother curve with the rectangular bars of a histogram, you can easily see it represents the same information. As before, the histogram here can be called normal, which has a mathematical definition. Conceptually, a normal distribution is symmetrical and shaped like a bell. This means that the data extends equally to the left and right from the most frequent value. In normal distributions, the mean, median, and modes have similar values. As a result, not only is the distribution centered at the mean, median, and mode, but the frequencies of these values decrease symmetrically, so other summary stats are affected like quartiles and standard deviations. In a histogram, this is represented with smaller and smaller rectangles extending outwards from the peak. There are many distribution shapes. Some of the more common ones are shown here. For each, the summary stats will change. For example, the mean is affected by outliers or extreme values in the data. However, the median is not. So in a skewed distribution, these values will differ, unlike the normal or symmetrical distribution, where mean and median are very close. As you get more familiar with summary statistics, you'll be able to spot a non-normal distribution by reviewing the stats instead of in a histogram. Often in statistics, you will want to test how normal the data is. Even though you can plainly see a bell curve shape, there are two mathematical aspects to a normal distribution. First, how much does the data lean or skew from the most frequent value? In the visual, it's shown with red arrows. A normal distribution will have little to no skew represented by the vertical red arrow. Second, to measure symmetry and how the tails of the data trail off, you review the blue lines. These aspects, leaning and trailing off, are measured in skew and kurtosis. In sheets, use skew and kurt along with the data range to get leaning and trailing off statistics. There are many opinions on acceptable values for skew and kurtosis to describe a normal distribution. Typically, I've seen that values between -2 and 2 for both can indicate a normal distribution. Adding a histogram in Sheets is straightforward. In the navigation ribbon, go to Insert, then Chart. This brings up the charting dialog. Select Histogram from Chart Type, and finally declare your data range for the variable of interest. In the upcoming exercises, you will calculate summary statistics and then see how the visuals change. Plus, you'll check for normal distributions using skew and kurtosis. In this section, we will transition from a histogram, which visualizes a single variable, to a scatterplot, which explores relationships among two variables. It's named scatterplot because each dot represents a row in your data, and the points often appear to be scattered along the coordinates. A scatterplot is great because your brain can identify patterns among the variables. In tabular form, identifying patterns or relationships may be difficult, especially if you have hundreds or thousands of rows. This small dataset shows the number of PhDs awarded in computer science and annual revenue for gaming arcades in the US. Each row represents a year of data sorted from smallest to largest. Now let's visualize this data as a scatterplot. Once in this form, it's much easier for you to see an upward and to the right general shape. To put it another way, as the number of PhD computer science degrees increases, so does the annual revenue for arcades. I bet you can picture a straight line running from the bottom left to the upper right. Even if the line has to run in between dots, you can identify the positive slope of your imaginary line. The imaginary line, also called a trend line, represents the relationship that as degrees increase, so does the revenue. In fact, in Sheets, you can add that imaginary line to a scatterplot to make it real. It's called a trend line to help you see the overall trend relationship. To add a trend line in Sheets, click Insert, then Chart. Once the chart dialog opens up, select Scatter Chart from the dropdown. Then ensure your data is declared properly. This will add a scatter plot to your sheet. The default is to leave out the trend line, so you have to click Customize in the dialog, and under the series, check the trend line box. You just brought your imagination to life to help you understand variable relationships. The trend line is added or fit so that the distance between the line and each point is minimized, represented by the green arrows. Other Datacamp courses go into much more detail about this type of line fitting. In fact, it's the principle behind linear models used by data scientists. So check those out if you're interested. For now, we'll stick with stats. Speaking of stats, in Sheets you can get the slope and intercept of the trend line using the lineest or line estimate function. It accepts two ranges and will return the slope, then the intercept. The intercept is the point at which the line touches or intersects the vertical y-axis. The slope can be interesting because it declares the trend relationship between the variables. For example, a slope of 1.5 means that as the x variable increases 1, the y variable will increase by 1.5. In our previous example, a slope of 1 would mean for each new computer science PhD, $1 billion more in arcade revenue would be realized. And if you have a slope of -1, that means as the x variable decreases by 1, the y variable will increase by 1. So negative slopes also tell you something about the relationship. Go make some scatter plots with trend lines. Good luck! In this next section, you will work with bar charts. These simple visualizations can be an effective tool for comparing frequencies of data, including factors like eye color, brown, blue, hazel, and so on. Sometimes you will have non-numeric data that you want to explore visually. The most common way to do this is by counting each type of non-numeric level. This data shows eye colors. You can't equate 1 to blue and 2 to brown eyes, but you can count each eye color and build this bar chart, which sums up the number of blue or brown eyes in your variable. Simply highlight the single column, then insert a bar chart in the dialog. If you have numeric data or can summarize levels through a pivot table, you can also use bar charts. The data now has gender along with eye color. Now when you insert a bar chart, you can compare gender by each category side by side. Use a side-by-side bar chart when you want to compare quantities by category like brown eyes. You can modify your bar chart from side by side to a stacked bar chart shown here. A stacked bar chart lets your brain identify the proportion of a variable within a level as part of the total. In contrast, side-by-side bar charts let you compare quantities, not proportions, among the category level. This is the same gender and eye color data visualized in a stacked manner. Now you can see that proportionally brown eyes are about even because the blue and red have similar areas, totaling almost 150. Lastly, another way to review this data is with a proportional stacked bar chart. Instead of raw frequencies, each column is colored by its proportion of the total in that category level. This view allows your audience to comprehend the proportional split in comparison to other categories, even if the quantities themselves are small. In previous visuals, the other bars were smaller because the values were small in comparison to the other categories. This made it hard to compare in a side-by-side or stacked bar chart. However, in a proportional stacked bar chart, all bars are the same height. This lets your brain focus on making categorical comparisons, from brown to blue to other, not just within a single category. Within the other category, now you can see that the red bar is longer than blue. Even though there wasn't many observations in the other category, this view shows a difference more clearly than previous visuals. In this chapter, data is related to auctions and their attributes, such as seller ratings and closing price. In this auction data, there is a category column with no numeric information. Instead, these are attributes of the auctions. In fact, they're distinct classes known as factors. You often learn a lot about the descriptive statistics of your data when you understand the frequency of meaningful factors and how they relate to another variable. So exploring a category and its relationship to other variables can be informative. For example, you may explore your data to find out that sporting goods auctions have a higher proportion of competitive auctions compared to other auction types. In fact, making multiple bar charts as part of your real-world auction analysis will help you spot these patterns in the data. You're doing great. Keep up the good work.